Hi, everybody. I'm Miss Cooksey, and today we're going to be talking about interpreting a graph in preparation to talking more about functions. So, we're going to go through 9 vocabulary words that have to do with interpreting a graph so that we feel more comfortable once we start graphing functions. So, the first vocabulary word we're going to talk about is linear. Linear has a keyword inside of it. That keyword is line. And if a graph is linear, it means it is a straight line. So it could be a horizontal line, a vertical line, or a diagonal line, but it's always going to be a straight line. Nonlinear is the opposite of linear, so it is not a straight line. So this could be any graph that's not a straight line. So here we have a quadratic function, an exponential function, a cubic function, or a piecewise function. It could also not fit in any of these categories whatsoever. Any graph that's not a straight line is going to be considered nonlinear. Next, we have an x-intercept. So intercept means intersecting, and this is where the line intersects the x-axis. So where the graph crosses the x-axis, and this is also where y equals 0, because if we're crossing the x-axis, we are going to be where y equals 0 on the y-axis. And the coordinate is always written as the x-coordinate where it crosses and a 0. The y-intercept is the opposite. It's where the graph crosses the y-axis. Whoops. Where the graph crosses the y-axis. So where x equals 0, and the point will be written as 0 and the y-coordinate for where the graph crosses the y-axis. Next, we have line symmetry. So line symmetry is going to be a vertical line, so a line that goes straight up and down, that splits the graph into 2 symmetrical parts. So line symmetry won't always exist on a graph, but if I can draw a vertical line that splits the graph into 2 symmetrical parts, then I have line symmetry. The graph is positive any place where the domain or the x values are above the x-axis. So any place where y is greater than 0. So we'll see this in a second, but anytime there's any part of the graph above the x-axis, that's where the graph is positive. Anytime there's part of the graph below the x-axis, that is going to be where the graph is negative. So the x values where it's above the x-axis are positive. The x values where it's below the x-axis are negative. The last piece that we're going to talk about is increasing and decreasing. The graph is increasing if the graph is going up, going up, going up. There we go. Sorry, there's a mirror situation happening here. The graph is going up as the graph increases from left to right. So if the graph is going up from left to right, then it's going to be increasing. If the graph is going down from left to right, then the graph is decreasing. So let's look at 2 different graphs and we're going to go through some examples. So the first thing we want to know is if it's linear or nonlinear. We're going to start with this graph. This graph is a straight line, so it is linear. Then we need to label the x-intercept. Well, this graph is supposed to cross the x-axis right where x equals 1 and y equals 0. So our x-intercept is 1, 0. Our y-intercept is where, let's see if we can draw a little point. So we have our x-intercept here, and our y-intercept is where y equals 1 and x equals 0. So that is the point 0, 1. Next, we have line symmetry. Well, in order to have line symmetry, I have to be able to draw a straight line, have my graph be the same on both sides of that line. That does not exist here, so there is no line symmetry. Next, we're going to be tracking to see where the graph is positive and where the graph is negative. So positive means above the x-axis. So the graph appears to be positive from here on. So all of this section is above the x-axis. So this is where the graph is positive. So we're going to write that as an inequality because we know that it's kind of starting at x equals 1 and then going to all the numbers less than that. So we're going to write that as it is positive wherever x is less than 1, or we can write it in interval notation and say it's positive from negative infinity to 1. We use a parentheses here because when it's at 0, it's neither positive nor negative. We're going to do the same thing for negative. Here we know it's negative from here on. So we're going to say when x is greater than 1, the graph is negative. Now, increasing is when our graph is going up from left to right. This graph is a straight line that's always going down from left to right. So it is never increasing, and it is decreasing for all real numbers. So no matter where you are on the graph will be going down. Now let's look over here at our quadratic. This is not a straight line, it's a quadratic graph. So it is a non-linear graph. And this graph actually crosses the x-axis twice. So it crosses the x-axis once here and once here. So the x-intercepts are -2, 0, and 0, 0. Because it's crossing at the origin, that's also where the graph is crossing the y-axis. So the y-intercept is also 0, 0 because it's crossing the graph is crossing the y-axis there. Now we have line symmetry. Well, for this graph, there is a place where I can cut the graph perfectly in half. Right through here. And let's see if we can make that a little narrower. So this line cuts my graph perfectly in half. There are mirror images on both sides. This is the line x equals -1 because it's crossing x at -1. And that's going to be how we write about line symmetry. Either there's no line symmetry or there's an equation where we say x equals and then wherever the line is. Next, let's look for where the graph is positive. Well, the graph here is positive in two places. It's positive before it drops below the x-axis, and it's positive when it comes back up. So we're going to write that as it's going to be positive when x is below -2 or when x is greater than 0 because it's above the x-axis here and above the x-axis here. The graph is going to be negative when it drops below the x-axis, which is this little section down here. So the graph is negative between -2 and 0. Last but not least, we need to talk about increasing and decreasing. So in this example, our graph will use purple. Well, let's make that blue. Our graph is increasing when the graph is going up from left to right. So it's going up, starting here, and going all the way this way. So that is going to be increasing when x is bigger than -1, because at this point, x is at -1. Notice we only care about the x coordinates for all of these pieces, and we're not so much worried about the y coordinates. The graph is decreasing. It's going down from left to right when x is less than -1. So it's going down when x is less than -1. That is where it is decreasing. Thanks for watching. Make sure you subscribe if you're in my class so that you never miss a video, and I'll see you next time.